Hi everyone, I'm Giovanni Di Stefano. I'm responsible for process technologies in Comau. Comau is a company that is part of FCA Group and is mainly devoted to robotics and automation systems. With almost 50 years of experience on industrial automation, we understood how much is important research and development, and that's why we decided to launch a challenge about automatic waste sorting. You can imagine how deep this technology will be connected with the construction environment, but of course it will be crucial for many other applications, especially in disaster recovery. Thank you very much.
Hundreds of armed conflicts are taking place as I speak. Hundreds of earthquakes occur every year in the world. Hundreds of disasters affect millions of people. What do all these events have in common? Of course, they have dramatic consequences on people's lives, but they also entail the destruction of cities and the huge generational debris. We all remember the L'Aquila earthquake. More than 2 million tons of debris was produced as a result of it, equivalent to about 50,000 of full loaded trucks and the disposal cost of hundreds millions of euros. Where do all these materials end up? Well, if you went there now, you will still find some of them. However, the vast majority of rubble ends up in landfills in the year following the disaster, and only a small fraction is recycled. But why is it so difficult to treat the disaster debris? Why is it so time and cost consuming? When we think about debris, we imagine bricks and stones, but it actually looks much more like this. Whatever object was inside the building will become rubble after the collapse. This is the reason why the separation of materials is a quite complex task. Recycling facilities and landfills are not specifically designed for disaster scenarios, and due to the involved quantities, overloads are common in both of them. Moreover, they are not necessarily close to the disaster site. This means that debris must travel extensively before disposal, resulting in increased costs and time for recovery, and the dramatic impacts on the environment. As a part of the waste management related challenge from Comau, we combine their specialization in automated systems with the idea that a good sorting is the key to extract value from the debris, and came up with an automated sorting system. This is then integrated in a wider automated process composed of different modules. Passing through them, valuable materials are gradually removed from debris, and residual waste is discarded. The final goal is to give new life to the most present ones, the aggregates. Now, let's drill down and see how the process works. The debris is loaded into the first module, where robotic arms pick recognizable bulky objects and potentially hazardous ones, removing them from the pile. Debris then enters the second module, consisting of a series of crushers, a sieve and a magnet. The crushers gradually reduce the dimension of material thanks to alternating fixed and moving jaws, while the vibrating sieve removes the liquids. Finally, the magnet extracts ferrous materials to be recovered. The third module is where the real sorting occurs. Materials are aligned thanks to a funnel, and the nearest sensor recognizes them. The deviators isolate valuable materials and separate the aggregates from the residual waste. In the last module, only the aggregates are treated. A grinder boils them down to sand, which is stored to be reused. To test the feasibility of the sorting phase, we developed a prototype which simulates the correspondent module of the process. Objects to be sorted run on a conveyor belt. The sensor recognizes them based on their visible spectrum and ignites the servo motor. It in turn drives the deviator, which directs the yellow and the black piece to different bins. By positioning several deviators in series, aggregates, other variable material, and residual waste can follow different paths. What is crucial in our solution is that the operations will be carried out on site, according to a mobile factory setting with the following features. It is transportable. There will be no need for debris transportation, because each module will be put inside a container that will be carried on site. It is modular. Containers can be easily connected to each other and transported only if needed. And it is flexible. The sorting technology can be set to isolate different types of materials. We can now point out the main advantages of this solution. It fosters value creation from waste and cut the use of landfills. It entails a reduction of logistics costs due to debris management. And finally, it speeds up the clearing rubble operation with a positive impact on reconstruction. Reshaping the reconstruction process is in fact our very ultimate mission. Starting from debris sorting and material recovery, we aim at extending the automation concept to the construction industry and push further the value creation while accelerating the recovery. This will enable to give a new life to the materials and to the people that suffered from the disaster. Last but not least, let me introduce the team that carried out this project. Feel free to reach out to us at this email address. Thanks for your attention.